This is Unit 1, Part 4. So we looked at a heterogeneous substance. Now we're going to look at start by looking at pure substance. So number 26. A pure substance is a sample of matter that has the same composition and properties throughout. Every sample of a given pure substance has exactly the same chemical properties. Every sample of a given pure substance has exactly the same composition. A pure substance cannot be separated into other substances without changing its identity or properties. So if I had let's say I had pure gold, no matter how much I cut it up, all the samples or all parts of that bar of gold are all going to be gold. They're going to have the same characteristics and properties, and the composition is going to be the same. And no matter how many times I cut it up, because it's a pure substance, I'm not going to change its identity. Pure substances are either elements or compound. So if you look at an element can be defined as a substance that cannot be separated into other substances by any ordinary chemical change. So again, if I look at let's say pure bar of gold, that's made up of the element gold. And no matter how many times I cut it up into smaller pieces, it's still going to be gold. And eventually I get to one atom, and then I can't really divide it up by ordinary means. Number 28, a chemical compound is a pure substance that can be decomposed into two or more simpler substances by an ordinary chemical change. We mentioned water before. Water is a chemical compound. So it's H2O. So that's water. It's a pure substance. So if I have a container of water, it's all going to be water, no matter how many, whether I have a tub full, a pond full, a pool, or a teaspoon. It's all water. That water can be broken up though, and we can break it up into hydrogen gas, H2, and oxygen gas. So this pure substance can be chemically broken apart into smaller substances because this is a chemical compound. Now, number 29, law of definite composition. A chemical compound contains the same elements in exactly the same proportion by mass, regardless of the size of the sample or the source of the sample of the compound. So let's go back to water. Water again, H2O. No matter how big the sample is that I have of water, again, whether it's a drop of water, a teaspoon, or a pool full of water, as long as it's pure water, I'm always going to have hydrogen, two of those, and oxygen, one of those. So it's always going to be a ratio of 2 to 1 of hydrogen to oxygen, no matter how big or small that sample is. Now in chemistry, we said that we have to measure some of the properties, and we can do that qualitatively and quantitatively. And when we look at different properties and measure them quantitatively, we use different units. So, and so if we read this, in order for scientists throughout the world, they need to be able to share information. So you have scientists that are communicating with each other about what their findings are or discoveries. In order for scientists for all around the world to understand published papers and to understand the quantitative information that's in there, we've agreed to use certain units. So if like a 30 gram, it's a unit for mass. So if I were to read a scientific paper from Germany, Egypt, Brazil, and the United States, they all would use the unit gram to measure out mass in a quantitative way. And for some reason I put mass here for length. It's supposed to be meter. So let me erase that. Let me try that again. Okay, so length. We use the unit, the meter, to measure length. And then for time, we use the unit second. And we can have very large numbers. So let's say you go driving, and you go driving, and you're going thousands and thousands of meters. Instead of writing out a long number to say how many meters you drove, we can use prefixes. And these are the prefixes some of the prefixes we can use. Mega, kilo, hectare, deca, deci, centi, milli, and micro. So let's say I went driving 1,000 meters, which really isn't that far. Instead of writing 1,000, what I can do is I can write out the prefix. So if you look over here, the prefix that indicates 1,000 is kilo. And then the unit, meters, is our base unit. So I can write that out as 1 kilo meter. Okay? If I had 100 meters, I could write 1 hectometer. Okay, now let's skip, deca. So if I have 10 meters, that is 1 deca meter. So you can see that these prefixes are really a shorthanded way of indicating multiples of 10. So if I look at a decameter, use 10 meters, and a hectometer, which is 10 times larger, is 100 meters. And then 10 times larger than that is 1,000 meters, which I use the hectometer. We also can write very small numbers this way too. So if I have a 1/10 of a meter, which is 0.1 meters, that's 1 decimeter. Okay, and then we can do 1 over 100 of a meter, which is 0.001 meters. I put too many zeros there, didn't I? Let's try that again. Okay, so it's 0.01 meters. All right, and this is 1. And if you look over here, centimeter. Okay, and then we'll do milli as the last one. So 1 over 1,000 of a meter is 0.001 meters, which is 1, so as our prefix, meter. Okay, so our next unit is the next one that you want to look at is Unit 1, Part 5.